Welcome to the lecture series on the topic temperature measurement. So in the last lecture we have just gone through the introduction of this chapter, that is what is temperature, then what are the different units of temperature. Again we have also seen how to convert the temperature that is given in one unit and how we can convert it into another unit. So basically we have seen those three scales, that is the degree Celsius, Fahrenheit and Kelvin scale. So you should remember how to convert the temperature from one unit to the other. Then again we have also seen what are the different temperature measurement methods. So if we consider the broad classification, then the temperature measurement can be done by two methods. The first one is by mechanical method, whereas the second is electrical methods. So in today's lecture we will see how to measure the temperature by using mechanical methods. So in this, the first type is liquid in glass thermometer. So I think that most of the students have already know about this type or this instrument. They may have also handled this instrument while measuring the temperature in their primary education level. So here is the working principle for liquid in glass thermometer. The expansion of fluid due to temperature. So this is the basic working principle for this instrument. Basically in this type of thermometer we are actually having one temperature sensitive liquid, and due to this liquid, since it is very sensitive to temperature, if even there is slight change in rise in temperature, then due to this rise in temperature the fluid inside the thermometer will start expand, and as a result of this, due to expansion of this fluid, we can measure the temperature. Okay, now let's see what is the construction of liquid in glass thermometer. So here you can see the diagram of liquid in glass thermometer. So it consists of several parts and few parts are mentioned here as well. So the liquid in glass thermometer, it consists of a glass tube. So here you can see this glass tube. Then again we are having one temperature sensitive fluid, or we can simply call it as responsive liquid. And the next is this scale. Okay, so this scale is usually engraved on this glass tube. So with the help of this scale we are able to determine the temperature of an unknown environment. Now let's see the working of this instrument. So in this instrument, uh, the main requirement is that if we want to measure the temperature of any environment, then this part, that is this is generally the bulb section of this instrument. So this bulb section should be kept in that atmosphere whose temperature is to be measured. So if the environment is having higher temperature, then the heat of that atmosphere will be absorbed by this fluid, that is which is usually used as mercury or alcohol. So this temperature sensitive fluid will detect the heat, or it will absorb the heat of that environment, and based on that temperature the fluid will start to expand. As I earlier mentioned, that the fluid which we are using here is highly sensitive to temperature. So due to if the temperature of the surrounding or that environment is high, then the liquid which is present in this bulb section, it will start to increase. So due to expansion of that liquid, the fluid will rise inside this capillary tube, and we have to wait for a certain time until this the rise in this inside this thermometer or inside this capillary tube becomes stable. The point at which the mercury level or the fluid level inside this becomes stable, we mark that point and just compare with this scale, and we will get the temperature of that environment. So it has simple working, and no such any skills are required for measuring the temperature by using this instrument. So here the general range for the instrument is given. If we are using mercury, then it is generally having the range in between -35 to 320 degrees Celsius. However, if we are using alcohol, then the range may vary from -75 degrees Celsius to 129 degrees Celsius. Again, if we are using toluene, then it may have temperature range from -80 to 100 degrees Celsius. So these are the temperature range. So this was all about liquid in glass thermometer. So here you can see how the liquid in glass thermometer, which you have already might have seen. Now we will move to the next instrument. Prior to that, we will just go through the advantages and disadvantages of this instrument. So as earlier I told that we are looking at the mechanical instruments which are used for measuring the temperature. So in advantages, if we consider this instrument for temperature measurement, then it is a very simple and inexpensive instrument as compared to the other types which we are going to see further. Then again, it is maintenance free, that is no any maintenance is required in this instrument. It is also having fair accuracy. Then again, disadvantages of liquid in glass thermometer. First disadvantage is automatic reading is not possible. So in general, if we talk about disadvantages of this instrument, then the main disadvantage while using this instrument is that it takes a lot of time, because while using the thermometer you need to wait until the liquid level becomes stable inside the capillary tube. Then again, another chance of error is while observing the scale there might be some mismatch. Okay, so these are the general errors which can occur when we are using the liquid in glass thermometer. So in order to avoid these disadvantages, we can go with another type of temperature measuring instruments. One last disadvantage, the instrument is fragile. So fragile actually means it can easily damage or broken, since the material which is used for this instrument is glass. So if there is any mishandling of the instrument, then it can easily damage or broke. Okay, so we will move now to the next instrument. So the next instrument for temperature measurement is a bimetallic strip, or we can also call it as bimetallic element or bimetallic thermometer. The working principle of this instrument is the coefficient of thermal expansion. So first we'll talk a little bit about what is the meaning of this coefficient of thermal expansion. So whenever we heat any element, then due to the addition of heat to that object, what actually happens is that we can observe that there is little bit change in size of that object. That is, with addition of heat to any object, there will be slight increase in the dimensions of that object. Or conversely, we can also say that if we are decreasing the temperature of any object, then the dimensions of that object will reduce a little bit. So different materials are having different values of coefficient of thermal expansion. So depending on the material, the coefficient of thermal expansion will be different. So now by using this principle, we are going to study how to measure the temperature by using this instrument. So this word bimetallic itself indicates that, or we can simply divide this word into two parts. So this bi means two and metallic stands for material, which should be metal. So bimetallic thermometer is made by joining two metals, and these two metals should be different, or the metals which are having different coefficient of thermal expansion. So here we will see the construction working. So if we look at the construction of bimetallic thermometer, then it consists of two different metal strips which are joined together, and in that one end of this joint material, we can see in this diagram, here two different materials are used. and one end of this material is fixed whereas the other one is free, or simply we can call it as a cantilever beam type. Okay, so this end is fixed and the other one is free, and these are the two different materials. So this white one indicates the metal which is having low coefficient of thermal expansion, whereas this black one which is indicated as another material, it is having high coefficient of thermal expansion. So these two metals are rigidly joined together to form a bimetallic strip. So this was the construction of a bimetallic thermometer. This instrument is available, or we can use this instrument in two methods. That is, the first one is the spiral type bimetallic thermometer, whereas the other one is helix type bimetallic thermometer. We will further see that how we can measure the temperature by using this instrument, because these points needs for explanation of these points we need to refer the diagram. So let's move to this diagram. So here in general you can see that there is some deflection. So this deflection is due to the applied heat. That is, if we take such bimetallic strip which is consisting of two different metals, and if we apply heat to this free end, then what is actually observed is shown in this diagram. So there will be a deflection due to the applied heat. One important point here is to note that this deflection will take place in the direction of the metal which is having low coefficient of thermal expansion. So as I earlier told that this white metal is nothing but it is having low coefficient of thermal expansion as compared to the bottom one. So on applying heat, there is deflection in the upward direction, that is towards the material which is having low coefficient of thermal expansion. So based on this working principle, we are going to measure the temperature. So here we can see this is the spiral type bimetallic thermometer. So one end of this thermometer, that is this one, it is fixed, whereas the free end of this bimetallic strip, it is connected to a pointer, and this is the calibrated scale. So on this scale we can have temperatures measurement. So if we keep this instrument in the environment whose temperature is to be measured, then based on the temperature of that environment, this bimetallic strip, it will start to unwind, and this unwinding motion will be given to this pointer, and thus the pointer will show the deflection. So with the help of this scale we can measure the temperature of that environment. So similar we can see here, this is spiral type bimetallic thermometer. Another type is that we are having a helix shape. So here the working will be same, one end is actually free, whereas the other one is connected to the pointer, and again we are having one calibrated scale. So with the change in temperature, this spring like structure, that is the bimetallic strip, it will unwind and give the motion to the pointer, and due to the motion of this pointer we will get the temperature on the calibrated scale. Okay, so for better understanding of the working principle of this bimetallic element, I have taken one example here. So this example is generally indicating what is the fuel level inside this tank. So whatever is the fuel level, we will be having that information on this display, and for this fuel level indication we are going to use this bimetallic strip. So now let's see how this bimetallic strip will help us to determine the fuel level. So inside this tank we can see there is some fuel level. We are having one rod to which a float is connected. So this float is actually a hollow one. So as the fuel level rises, this float will also rise, and if the fuel level decreases, then this float level will come to bottom level. So the movement of this float causes the angular displacement of this wiper. So if we consider the tank is full, then what will happen, this float will rise upward, as a result of which this wiper will turn towards the left. Now we can see that here is the resistor. So resistor will oppose the flow of current, but if the wiper is at extreme left position, then what will happen, the current will not flow through this resistor. Instead, this current will flow through the wiper, through this line, which will cause this bimetallic strip to gain more heat. Okay, so as a result of this, if this strip gets more heated due to more flow of current, then it will start bending as shown in this diagram towards this left direction, and the movement of this bimetallic strip, it will cause this indicator to move towards the full indication. On the other hand, if we consider that the fuel level is very less, then due to the decrease in fuel level, this float will go downwards, then this wiper will move towards the right, and as a result there will be some resistance in the current. Okay, so when the current will flow through this part, there will be some resistance, and as a result less current will flow to this bimetallic strip. Since less current is flowing through this bimetallic strip, it will be less heated, and as a result this the deflection which was earlier, now the deflection will be less. So accordingly, with the movement of this bimetallic strip, this pointer will be indicating now less fuel. So this is how the bimetallic strip works. Now we will see the next instrument, that is the pressure gauge thermometer. So this one will be the last instrument for temperature measurement under mechanical category. So the working principle of pressure gauge thermometer is the expansion of fluid due to temperature. If the expansion is restricted, then the pressure will increase. So we will go in detail with this instrument. So basically, if we look at the pressure gauge thermometer, then they are available in two types, that is a liquid pressure thermometer and vapor pressure thermometer. So this thermometer or this instrument is basically the combination of two instruments. One is the Bourdon tube pressure gauge, whereas the other one is liquid and glass thermometer. So here we can see the construction working, that is different parts which are we can observe in this instrument. So first one is the bulb, capillary tube, pressure measuring device, pointer, a metal bulb containing the thermometer fluid, that is temperature sensitive fluid, which is placed at the desired place. Okay, so we'll discuss this with the help of a diagram. So here we are having this diagram for liquid pressure thermometer or pressure gauge thermometer. So this is the bulb section. Then again, this is the part which we can consider it as the part of Bourdon tube pressure gauge. So the free end of this Bourdon tube, it is connected to a link which is further connected to a pointer which indicates the value of temperature on a calibrated scale. So as I told earlier that this pressure gauge is consisting of two different parts which are combined together to form this instrument. Again, we can see here also, so up till this part we can consider that it is a thermometer, and beyond this part it is similar to what we called it as Bourdon tube pressure gauge. So we know the working of liquid and glass thermometer as we have already discussed. So similar working will happen here. The temperature of the environment which we want to measure, this bulb section is to be kept in that environment. So depending on the temperature of the environment, the expansion of fluid which is present in this bulb section, it will rise, and it will cause this spiral tube, or we can say this Bourdon tube, to become straight. So due to the pressure of this fluid, this C-shaped tube, which is called as a Bourdon tube, it will try to become straight, and due to this movement, or this movement will be transferred to this pointer via this link, and accordingly we will get the temperature on this scale. As we discussed in previous slide, that the temperature indication or the working principle of this instrument is based on expansion of fluid. So the amount of expansion of this fluid depends on the temperature of the environment whose temperature is to be detected. So depending on the temperature, the expansion of fluid will take place, and this expansion will cause the deflection of this Bourdon tube, or we can say in this diagram, unwinding of the spring. And since the free end of this Bourdon tube or this spiral tube is connected to the pointer, this deflection will cause the pointer to deflect, and the deflection of pointer will give us the temperature.